Hello again. Welcome back. Today, as you can see, we're going to talk about a very important topic, one that is going to come back in most of the systems we talk about. You probably pick out an example of this, but homeostasis. It's a very important topic for biological systems, and found this nice image to illustrate its importance. You need to maintain homeostasis. If you don't, you will probably be dead. All right, so homeostasis. You may already kind of figure out what it means based on the word roots, but let's look at it. What is it? What is homeostasis? Homeostasis is really keeping the same state, maintaining those same internal conditions. All right, you get the homeo part, which is the same, and stasis or status, state, right? Maintaining that same state. This little equilibrium. Nice, another great image I found. Right, you want to keep this nice, delicate balance. So everything in a human body, in any living organism, is regulated at some sort of level, and the organism needs to maintain it at that level. Otherwise, bad things will happen. There will be some sort of disease you gotta fight and use medication to do, or you might, in worst case scenario, you die. So let's take a look at some of these examples. Right, again, what it is, right? Maintaining the same internal conditions, maintaining that same state. All right, so the first, most obvious one that you usually go to is body temperature. Right, regulating that body temperature. I don't know why I changed it to 98.7. I had 98.6 earlier, and then I changed it to 98.7. Your normal body temperature, each person's a little bit different. It does adjust throughout the day. When you wake up in the morning and your temperature is a little bit lower than it would be after you start activity. And that body temperature is going to be closely associated with how much activity you do, since if you remember from early on in the year, cellular respiration, the bulk of that energy and glucose is lost to heat. So the mechanism within the body to control this, if you go too low, if you get too cold, like in the wintertime, what happens is you start to shiver. Right? Your body kind of starts muscle contraction underneath the skin. That muscle contraction is going to use energy and cellular respiration, and which is going to release heat, which could help minimally maintain your body temperature, raise it up a little bit. It also is going to help. It's going to constrict some of the blood vessels to the surface near your skin to kind of keep the cold away from the heat exchange there. But you do have a mechanism. And if your body temperature starts getting too high, if you're too active when it's hot outside, it's dangerous. And if it gets too low, you get hypothermia and die. If you get too hot, you get heat stroke and die. But your body's built some mechanism there is to sweat. Right? You'll release water. And if you look at water itself, it absorbs a ton of energy when it evaporates. And the idea is that when it evaporates off your skin, it's taking your energy with it. So as that water evaporates, it takes your energy away and therefore cools you down. So in homeostasis, you want this body temperature, plus or minus a few degrees. You get outside that range, then you're going to have these effects, right? Shivering, sweating, and your body's going to try to adjust to keep you healthy, to keep you from dying. Blood glucose levels. Another example that is regulated. Right, we're looking at two compounds here, insulin and glycagon. But if we have, you've got your regular homeostatic levels there, and if you have too much glucose, if your blood glucose levels are too high, you release insulin, and then the insulin will allow the cells to take in glucose, or allow glucose to be stored in the liver. Again, remember that from earlier on in the year. It turns into glycogen, and as a result, your blood glucose levels decline. And then if your blood glucose levels drop too much, right, you need to take that glucose out of the liver. Right, there's a molecule called glycagon, not to be confused with glycogen, but glycagon, which is released, then takes the glycogen out of the liver and puts it as glucose into the bloodstream. If you are diabetic, you have an issue with the insulin, right? The insulin levels, so you don't have a way to regulate the blood glucose levels that are high, right? Getting that glucose out of your blood. And then one of the big factors there is getting the glucose into the cells. And if you can't get glucose into the cells, they will starve of energy, cellular respiration, and that can lead to problems. One sign of if you're diabetic is weight loss, because what will happen is if your cells cannot get glucose inside, you need energy, and they'll start taking it away from the fat cells and processing that so that you don't die. If we were in class, I'd tell you about my diabetic cat, but don't want to. If I had a picture of it, maybe I would, but I did have a diabetic cat that needed to get shots, I think, 2 times a day. All right, other examples. Everything. If you name something in the body, it's probably regulated. And there's more than just what I listed here. You get iron levels, calcium levels, blood pH levels, blood pressure, sodium levels. Goodness, I just had one in my the osmoregulation, the fluid levels, ion concentrations. Virtually everything in humans is going to have some sort of level that you need to be within, and if it's not, the body will adjust to reestablish that homeostasis. And I have blood calcium levels, another one that you'll see quite frequently. You've got these, again, usually have 2 compounds that have the opposite effect, that work in conjunction with maintaining a particular level. In this case, you have calcitonin and you have the parathyroid hormone, which work together to make sure that you have calcium levels. All right, that's pretty brief today, but homeostasis, again, very important, maintaining those same internal conditions. And really, that's it. So 7.5 minutes, pretty good. See you later.